Hello friend, today we will discuss here the elimination reactions. In the elimination reactions, we can explain here the detail how to elimination reactions proceed, then what are the final product of the elimination reaction, what are the types of elimination reactions. Explain one by one the what is elimination reactions. In the name, that is elimination, that means there is a removal of some molecules from the substrate molecule to form a product molecules. Generally, in elimination reaction, there is losses of two atoms or group from the adjacent carbon atoms form a multiple bonded molecules. In today's lecture, we can discuss here the beta elimination reactions. In the beta elimination reactions, the two atoms or two groups lost from the adjacent carbon atoms, it is called as beta elimination reactions. It also known as 1,2 elimination reactions, that is 1,2 elimination reactions, that is eliminating group eliminate from the carbon number 1 and carbon number 2 to gives rise to new double bonds or triple bonds. With the examples, these are the alpha beta carbon atoms, and these alpha beta carbon atoms contain these are the hydrogen atoms and these are the halogen, that is these are the dihydrohalogen reactions, that means elimination of hydrogen as well as halogen atoms from the adjacent carbon atoms to form carbon carbon double bond, that is formation of multiple bonded molecules with the elimination of HX. These are the general mechanism of the elimination reactions. The beta elimination reaction can be take place in the three different reaction mechanism called as E1 reaction, E2 reaction and E1cb reaction. These are the depending upon the nature of the reactant, that is nature of the substrate is important whether the reaction is E1, E2 or E1cb reactions. Now we can explain the detailed mechanism of the reaction, that is E1 reaction, E2 reaction and E1cb reactions. The first example of beta elimination reaction, that is E1 elimination reaction. Here E stand for elimination and 1 stand for the unimolecular reactions. The rate of reaction depend upon the only one substrate molecule, therefore this reaction is known as E1, that is elimination unimolecular reactions. Now here we can explain the detailed mechanism of these E1 reactions. Here the tertiary bromide reacted in presence of alcoholic KOH, that is here OH minus ions to form CH3 C double bond CH2, here CH3 with elimination of water molecule as well as bromide ion. Mechanism of the reaction, here the nature of substrate molecules is a tertiary halide. Here CH3, the centered carbon atom bonded with Br atom CH3, these are the CH3, here these are the bromine. Here Br is more electronegative than the carbon atoms, therefore the Br del negative and the centered carbon atom del positive ions. The three groups, the electron donating groups, therefore flow of electron from this CH3 group toward the centered carbon atom. Here again same, here again same, but here the bromine is more electronegative than carbon atom, therefore flow of electron from centered carbon atom toward this Br atoms. Therefore in this case these molecules, that is tertiary halide itself ionize to form more stable tertiary carbocation ions. Broken bond indicate these are the eliminating groups eliminating from these carbon atoms. Bromine eliminate with its bonding pair of electrons, therefore these are the slow step of these reactions to form the more stable. Now this Br eliminate with its bonding pair of electrons to form CH3, here CH3, CH3, and then the centered carbon atom contain positive charge, that is formation of tertiary carbocation ions. According to stability order of the carbocation ions, the tertiary is more stable than the secondary than the primary. In this case, there is formation of tertiary carbocation ions, therefore these are the more stable than the other. Therefore, in this step first, the substrate molecules itself ionize to form more stable carbocation ions without any reacting molecules. Therefore, first step of this reaction, the OH minus ions, that is base abstract H plus ions, and then this bonding electron shifted toward the electron deficient carbocation ions and these CH2 carbocation ions to form a single to double bonds. Here these are the broken bond indicate eliminating from this substrate molecule and to form a double bond, single to double bond, with this double bond to form final product of this reaction, that is formation of CH2 double bond CH3 with the elimination of water molecule. In this reaction there are two steps, and in the step first, proceed with the very slow rate. Therefore, this step first determine the overall rate of reactions. Therefore, this reaction is known as E1 elimination reactions. In the step first, that is rate determining step, there is only reacting molecules are participate. Therefore, this reaction is also known as elimination unimolecular reaction. That means in the rate determining step only reacting molecules are participate. Therefore, these are the E1 reactions. In the step second, the reagent molecule attack to form a final product. E2 reaction, elimination by molecular reaction. In the rate determining step, there is two molecules are participate, that is reacting molecules as well as reagent molecules are. In the E2 reaction, the nature of substrate is the primary highlights. Therefore, the both reactant and reagent molecules react simultaneously to form a final product of these reactions. Now here the base abstract acidic proton atoms. Now this bonding electron shift to form a single to double bond. At that time, this Br eliminate with its bonding pair of electrons to form final product of this reaction. This reaction take place with the transition state. Here the elimination take place to form a final product of this reaction, that is CH3 CH double bond CH2 with the elimination of water molecule as well as bromide ion. The rate of reaction depend upon both the substrate as well as the reagent. Both reactant and reagent molecules participate in the rate determining step. Therefore, this reaction is known as elimination by molecular reaction. In E1cb reaction mechanism, here the E for elimination, 1 for unimolecular and Cb for conjugate base reactions. In the dehydrohalogenation of alkyl halide having strong electron withdrawing groups like CH, Cl2, CF3, such types of molecules reacted in presence of strong base like C2H5 ONA. Here this reaction proceed with heating condition to form Cl2 double bond CF2 with the elimination of C2H5OH as well as NAF. Now the detailed mechanism of the reaction, this reaction proceed with the two-step reactions. The step first in this step first there is H plus ions, that is proton abstraction take place. Now in the substrate molecules, the strong base abstract H plus ions to form carbanion, which is stabilized by electron withdrawing groups. Therefore this is also called as carbanion mechanism. In this step first is only acid base reaction, in which the carbanion is the conjugate base. Now here the formation of this substrate molecule reacted in presence of strong base. These are the base. Now base abstract the acidic proton atoms, and this bonding electron shifted toward the carbon atoms to form the base abstract H plus ions, and this bonding electron shifted toward the more electronegative carbon atoms. The abstraction of H plus to form a carbanion, that is known as conjugate base. In this step second, the elimination and formation of double bond take place. The carbanion, that is conjugate base, loses the leaving group, that is halide, to give as alkene molecules. This is first order reaction with respect to the conjugate base, that is Cb. Hence this reaction is known as E1cb mechanism. Now here this bonding electron shift to form a single to double bonds, and these more electronegative groups, that is fluoride ion, eliminate with its bonding pair of electrons. In the transition state, this bonding electron shift to form a single to double bond, and these fluorine eliminate with its bonding pair of electrons to form single to double bond, that is formation of product Cl C double bond C, the already present group, that is fluorine. These are the F, here Cl atoms, that is formation of 1,1-dichloro 2,2-difluoroethene, 1,1-dichloro 2,2-difluoroethene as a final product of this reaction.